This is SpaceTime, Series 23, Episode 57, for broadcast on the 10th of June 2020. Coming up on SpaceTime, a new type of cosmic explosion, claims galactic collisions may have triggered our solar system's birth, and Europe's spaceport back in business. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered two new events which are very similar to a strange, inexplicable explosion which mysteriously blasted across the cosmos in 2018. These events, which astronomers are calling fast blue optical transients or FBOTs, share some characteristics with the supernova explosions of massive stars and with explosions that generate gamma-ray bursts. But they also have distinctive characteristics that make them appear to be entirely different entities. Our story begins back in June 2018, when astronomers detect a cosmic explosion with surprising characteristics and really strange behavior. The object was catalogued as AT2018 COW, and with a code like that, it forever became simply known as the cow. It quickly drew worldwide attention from scientists who have been studying the object extensively ever since. Over a period of just 3 days, the cow produced a sudden explosion of light at least 10 times brighter than a typical supernova, and then faded gradually over the following few months. This unusual event occurred either inside or very near a star-forming galaxy known as CGCG 137068, located about 200 million light-years away in the constellation Hercules. While the cow shared some characteristics with supernova explosions, it differed in important aspects, especially its unusual initial brightness and how rapidly it brightened and faded in just a few days. That led to speculation that this might have been a tidal disruption event involving a white dwarf star being grabbed, torn apart, and ultimately consumed by a black hole. In the meantime, two additional explosions, one in 2016 and another in 2018, also showed the same sort of unusual characteristics. The two new explosions were catalogued as CRTS CSS 161010 J045834-081803, which occurred in a galaxy about 500 million light-years away, and ZTF18 ABV KWLA, which quickly became known as the Koala, in a galaxy about 3.4 billion light-years distant. Both these objects were discovered by automated sky surveys, and both gave astronomers a lot of surprises. The lead author on the Koala study, Anna Ho from Caltech, the California Institute of Technology, immediately noted that the object's radio emissions were as bright as that from gamma-ray bursts. While Diane Coppergens from Northwestern University, who led the study on CSS 161010, noticed that her object had ejected an unexpectedly large amount of material into interstellar space at more than half the speed of light. In fact, it was so unusual, it took her team more than 2 years just to figure out what they were looking at. But in both cases, follow-up observations indicated that these objects shared similar characteristics and features with the cow. Reporting in the Astrophysical Journal and the Astrophysical Journal Letters, the authors have concluded that these three fast blue optical transient events represent a new type of stellar explosion, something completely different from anything else. The authors think FBOTs probably begin the same way as some supernovae in gamma-ray bursts. That is, when a star far more massive than our Sun explodes at the end of its life in what's called a core collapse or Type 2 supernova. But the differences show up in the aftermath of the initial explosion. See, in a regular core collapse supernova, the explosion sends a spherical blast wave of material into interstellar space. However, the authors suggest that FBOTs also briefly form a rotating accretion disk of material around the neutron star or black hole that's left after the explosion. And this generates narrow beams of material at nearly the speed of light outwards in opposite directions, perpendicular to the accretion disk, sort of like a quasar or microquasar. These jets can produce narrow beams of gamma rays, causing a gamma-ray burst. Astronomers refer to these rotating accretion disks and the jets they produce as an engine. And FBOTs also have such an engine, but in their case, unlike a gamma-ray burst, it appears to be enshrouded in thick material. That material was probably shed by the star before it exploded, and may have been pulled from it by a binary companion. When the thick material near the star is struck by the blast wave, it causes the bright visible light burst soon after the explosion that initially made these objects appear so unusual. And it's that bright burst which is why astronomers call these blasts fast blue optical transients. It's one of the characteristics that distinguish these events from ordinary supernovae. As the blast wave from the explosion collides with the slower moving material around the star as it travels outwards, it produces radio emissions. And it's this bright emission that was the important clue that proved the explosion was powered by an engine. This shroud of dense material means the progenitor stars different from those leading to gamma-ray bursts. In the case of the Kourou and CSS 161010, the dense material included hydrogen, something never before seen in gamma-ray bursts. Using the Keck Observatory, the authors found that both CSS 161010 and the Koala, just like the Kourou, appeared to have originated from small dwarf galaxies. And that suggested the properties of dwarf galaxies, maybe their high dark matter content, who knows, might allow stars to undertake some very rare extraordinary paths that lead to these distinctive types of explosions. Although a common element of the FBOTs is that all three appear to have a central engine, the authors caution that the engine itself could also be the result of a star being shredded by a black hole. Which I guess means the jury's still out. This is SpaceTime. Still to come, the galactic collision which may have triggered our solar system's birth, and Europe's spaceport back in business. All that and more still to come on SpaceTime. The formation of the Sun, the solar system, and subsequently the emergence of life on Earth may all be a consequence of a cosmic collision between our Milky Way Galaxy and a smaller satellite galaxy known as the Sagittarius Dwarf. Ever since it was first identified in 1990, astronomers have realized that the Sagittarius Dwarf galaxy's orbit indicates that it must have collided with and smashed through the disk of our Milky Way Galaxy on multiple occasions. In fact, computer simulations now suggest that it's impacted the disk of the Milky Way, punching right through it on at least 3 separate occasions over the past 6 billion years. And the immense gravitational tidal interactions generated during these colossal events have had a profound effect on how stars move within the Milky Way Galaxy, and may even be responsible for the Milky Way spiral arms. Now, a new study, based on data gathered by the European Space Agency's Gaia galaxy mapping satellite, suggests the Sagittarius Dwarf's influence on the Milky Way may be even more substantial. A report in the journal Nature Astronomy points out that the ripples caused by these gigantic collisions would have triggered major star formation episodes. And according to the study, one of those episodes roughly coincides with the time our Sun and Solar System were formed some 4.6 billion years ago. The study's lead author, Thomas Ruiz Lara from the Astrophysics Institute of the Canary Islands, says existing models show Sagittarius Dwarf fell through the Milky Way on at least 3 occasions. The first about 5 or 6 billion years ago, then again about 2 billion years ago, and the final one around 1 billion years ago. And the Gaia data shows 3 periods of increased star formation, which peaked at 5.7 billion years ago, 1.9 billion years ago, and 1 billion years ago, roughly corresponding with the time when Sagittarius is believed to have passed through the disk of the Milky Way. The authors looked at luminosities, distances, and colours of stars within a sphere of about 6,500 light-years of the Sun, and then compared the data with existing stellar evolution models. They say the collisions would have disrupted the Milky Way's equilibrium, causing previously still gas and dust to slosh around like ripples on water. And these ripples would have increased the concentrations of molecular gas and dust clouds, causing some to collapse and trigger starburst, the sudden spontaneous formation of millions of stars. And the authors speculate that our Sun, consequently solar system, formed after the first of these collisions between Sagittarius and the disk of the Milky Way. Each of these collisions has stripped Sagittarius of some of its gas and dust, leaving the galaxy smaller after each passage. The authors say that their data suggests that Sagittarius may have even passed through the Milky Way's disk again quite recently, in the last few 100 million years or so. And even now, observations show that it's awfully close. In fact, the authors have found a recent burst of star formation which they suggest is a possible new and ongoing wave of stellar burst from just such a collision. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
This dwarf galaxy that keeps smashing into the Milky Way, and they now believe perhaps that it's why we exist, why our solar system is here, which does make for a compelling story, I imagine.
Indeed, it does. It's a great story, and it's actually very close to home, is this, Andrew, because the dwarf galaxy that we're talking about that smashed through the plane of the Milky Way was discovered at the United Kingdom Schmidt telescope. So it was a discovery made. The research paper discovering it actually was published in 1994. I think I'm right in saying that. Actually, it might have been 1995, which is the year I took over as astronomer in charge. But I worked there before I was astronomer in charge. I worked there for 10 years as just one of the oiks taking photographic plates, and that was how this dwarf galaxy was discovered. So, all right, what's the story? And really what allows us now to make the absolutely exquisite observations that this story requires. The facility is the Gaia spacecraft. That's the new part of this story. Gaia is a European mission, was launched 5, 6, 7 years ago, maybe. It's essentially doing absolutely high precision measurements of the positions of stars in our galaxy, the Milky Way Galaxy. And its total, I think so far, is about 1.5 billion that they've measured. It's a huge number, many, many more than we ever did with the telescopes like the Schmidt back in the 1980s. But they also measure their velocity. So what the Gaia data have shown us is the way these stars are moving. And so the Sagittarius Dwarf Galaxy, and as you can guess, it's principally in the constellation of Sagittarius. We've known for a long time that this is one of the dwarf galaxies that is in orbit around our own Milky Way. And more than that, it's actually being dismantled by the Milky Way. The two best examples are the Large and Small Magellanic Clouds. They're much, much bigger than the Sagittarius Dwarf, but they are two being torn apart over timescales of millions of years, hundreds of millions of years probably, and eventually will wind up as part of the halo of our galaxies, that halo of stars that surrounds our galaxy. The Sagittarius Dwarf is in the same boat. It's being torn apart by tidal forces, but it's much smaller and it's actually nearer to the plane of our galaxy than the Magellanic Clouds. And what's now happened is that because of the observations of the Gaia program, the Gaia spacecraft being able to measure these star positions very accurately, what it means is that you've only got to wait 2 or 3 years. Actually, it's probably about 5 years, but you measure them again and they've moved. And so you can actually work out how fast these stars are traveling. And so they've done that for the Sagittarius Dwarf. And that then allows you to track back as to where it's come from and how it has behaved in its interaction with the Milky Way Galaxy. And so the models that allow you to do this show that the Sagittarius Dwarf Galaxy has basically fallen through the plane of the Milky Way 3 times.
Oh, wow.
First one was about 5 billion years ago, then again about 2 billion years ago, and the third time only 1 billion years ago. And what they're saying, and I should say this is research that's done by astronomers at a place I used to have a lot to do with, Instituto de Astrofísica de Canarias, which is the Canary Islands Astrophysical Institute. Pardon my Spanish. It's in Tenerife. They operate telescopes in La Palma, and I used to work there quite a lot because there's a British facility there as well, or it was. It's now much more collaborative than that. So what they looked into was, first of all, the model, and the model shows that the Sagittarius Dwarf has whacked through the Milky Way 3 times. But you can come at this from a different angle. You can look at the star formation history in our galaxy, and you can do that by looking at star colors, luminosities, distances. You can basically do this giant analysis because there's such a huge amount of data coming from Gaia. And it turns out that our Milky Way has 3 periods of increased star formation, which peaked 5.7 billion years ago, 1.9 billion years ago, and 1 billion years ago. And they're exactly the times that the Sagittarius Dwarf is believed to have kind of punched its way through the disk of the Milky Way. So what's happening here is that gravitational interactions, as this dwarf galaxy with all its stars passes through the Milky Way, they trigger the formation of new stars because there's the plane of the Milky Way is rich in hydrogen, and that's the raw material of stars. So this disturbance is what there's a kind of compression of gas, and that actually kicks off the star formation. And so what they are suggesting is that that period of enhanced star formation 5.7 billion years ago is probably what you might call the same batch of star formation, the same period of star formation in which our sun formed. The sun formed about 4.6 billion years ago. So it's a little bit more recent than that, but the sun could be part of the end wave of this star formation that was caused by that first transit of the dwarf galaxy through the disk of the Milky Way. It's a very nice story, I have to say. It brings together the many facilities that we've got to do astronomical research these days, but in particular the Gaia project, which is really an excellent project and is doing remarkable work.
Yeah, and these galactic collisions are not unusual, really, are they? I mean, we've talked before about our impending collision with Andromeda in 60 gazillion years' time, but these things are happening all the time. There's a couple of others that are happening as we speak, are there not?
Yeah, there are. Most famous are the antenna galaxies, two galaxies that are very close together, and their spiral arms are kind of being spread out, and it looks just like an ant with two giant antennae sticking out of its head, which is why they call the antenna galaxies. And that's the disturbance that's sort of stripping off the spiral arms of the galaxies. And now that sort of thing happens when you've got two galaxies of a similar size colliding, and it's what will happen. And it's about 3.5 billion years. 3.5 billion years down the track, this is going to happen to ours. That's probably what the end product will be. It'll take a few billion years to settle down, but we might wind up looking a lot like the antenna galaxies. I've seen simulations of what this will be like. But with a dwarf galaxy colliding into a big galaxy like ours, the outcome is different, because the big galaxy has enough mass that its shape is not dramatically affected. Although these authors are suggesting that those collisions with the Sagittarius Dwarf through the plane of our galaxy might well have given rise to the spiral structure that we see in our own galaxy now, that maybe it had a different spiral structure before that. And what we're seeing in terms of our spiral structure, and we can map it using infrared and radio telescopes, that might be a result of these collisions, which is itself an interesting idea.
Yeah, and the bottom line being that mathematically the timing is exactly right for the birth of our sun, therefore our solar system.
Yep, so we might not have been here without all this, which is a very sobering thought.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. The idea that our sun and solar system were formed out of the collision of the Milky Way with another galaxy wouldn't be radical. After all, we've seen just such collisions in other galaxies and the tremendous amount of star formation they produce. Of course, as far as our sun is concerned, there are other studies, lots of them, which suggest that a nearby supernova explosion about 4.6 billion years ago most likely triggered the collapse of the molecular gas and dust cloud, which eventually gave birth to our sun and solar system. Evidence supporting this has been found in the ratio of aluminum isotopes found in meteorites formed during the molecular cloud collapse. The isotope aluminum-26 usually has a half-life of about 700,000 years, eventually changing into magnesium-26. However, the ratio of aluminum isotopes in ancient carbonaceous chondrite meteorites known as CV chondrites is unusually high. And remember, it's these CV chondrites which are thought to have formed directly out of the collapse of the molecular cloud that gave birth to our solar system. The unusual isotope measurements suggest that fresh aluminum-26 was being fed into the molecular cloud as it collapsed, either by stellar winds from a local star or by a blast from a nearby supernova explosion caused by the death of a star. And the models showed that a supernova event some 15 light-years away was the most likely trigger. The blast's shock front and hot gases travelled through space, eventually colliding with the molecular cloud of gas and dust, causing it to quickly collapse, forming our sun and solar system. The model provides the right ratios of aluminum isotopes to explain the levels found in CV meteorites. The CV chondrites probably formed as the temperature of the gas cloud dropped below 1800 degrees Celsius. The model also shows how this would have occurred over a period of just 20,000 years, again matching the isotope measurements, which acted like timestamps, marking the formation of these meteorites to within 20,000 years of each other. This is Space-Time. Still to come, Europe's spaceport back in business following COVID-19. And Beijing launches 2 more spy satellites. All that and more still to come on Space-Time. The European Space Agency's Kourou spaceport in French Guiana is beginning to get back to work following the COVID-19 coronavirus lockdown. The deadly pandemic, which has infected over 6.5 million people and now claimed more than 400,000 lives, spread globally from its Wuhan epicenter after China's communist government denied the existence of the virus. As the pandemic spread, the European Space Agency placed the Kourou spaceport into lockdown in March. The move saw all but safety-critical operations suspended and the vast site secured. The shutdown impacted launch schedules for both Ariane 5 and Vega missions, as well as construction work on the new Ariane 6 launch complex. Strict new safety and hygiene procedures have now been introduced, and launch teams returning to the complex from mainland Europe will need to spend 2 weeks in quarantine. Vega is due to return to flight within the next few weeks, with its first rideshare mission dedicated to small satellites using Vega's new small spacecraft dispenser. This report from ESA TV.
2020 was shaping up to be a busy year for Europe's spaceport in French Guiana. 5 Ariane 5 launches were planned. Preparations were well underway for a Vega launch. And work was nearing completion on the new Ariane 6 launch site. But then COVID-19 struck. With lockdown measures imposed in mid-March, operations halted. The vast site had to be secured and the launchers made safe.
We were just in the launch campaign of the next Vega flight, the VV16, and we had first to secure the launcher, especially the upper stage, the last stage of Vega had to be flushed. On the other side, we had also to take care of the payloads. We have 42 CubeSats and microsats on this launch campaign, and they have to be brought back in the payload facility buildings.
Now, with only a few personnel on site and a backlog of launches, the challenge is to safely resume operations.
The next step is for us to organize the comeback of the European workers who left French Guiana just before the lockdown.
When they arrive, they'll spend 14 days quarantined, and workers have to follow strict safety and social distancing rules. In tunnels beneath the new Ariane 6 launch complex, work is resuming, fitting out the control and fire suppression systems. Pipes will carry tens of thousands of litres of water a second to combat the extreme heat of launch. The assembly building and launch pad are nearing completion. It's not yet clear what impact COVID-19 will have on the launch schedule. In the meantime, the existing launchers have plenty of work.
Right now, we are putting priority 1 on the return to flight of Vega. And the launch campaign is running. We expect the launch mid-June. This should then be followed by a second flight of Vega, let's say around the second half of August, and the third flight by the end of the year.
With 2 more Ariane 5 flights also planned, Europe's spaceport is slowly getting back to business.
And in that report from ESA TV, we heard from ESA's Director for Space Transportation, Daniel Neuenschwender, and ESA's Technical Manager, Tony Dos Santos. This is SpaceTime. Still to come, Beijing launches 2 more spy satellites, and later in the science report, how to stop COVID-19 spreading among family members. All that and more still to come on SpaceTime. China is further increasing the vast number of military spy satellites it now operates, launching a further 2 into orbit. The new spacecraft were flown aboard a Long March 11 rocket, undertaking its maiden flight from the Jiaqiang Satellite Launch Center in southwestern China's Sichuan province. The Long March 11 is a 4-stage solid-fueled rocket designed as a quick reaction launch vehicle which can be readied for flight with little notice. This mission represented the 9th flight for the 21-metre-tall launch vehicle, which can carry a 350-kilogram payload into a 700-kilometre-high sun-synchronous low-Earth orbit. Beijing's describing the 2 spacecraft, the Jinzhujian G and H, as new technology experimental satellites. That's a euphemism for what usually refers to military spy satellites. They'll be used to undertake ground observations and test inter-satellite telecommunication systems. China's People's Liberation Army already operates more than 80 spy satellites, providing the Communist government with unprecedented reconnaissance overview. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New research suggests that wearing face masks at home may be one way to stop COVID-19 spreading between family members. But the catch is it only works if they're worn before symptoms develop, which I guess means you've got to wear them all the time. A report in the British Medical Journal surveyed some 460 people from 124 families who had at least one member suffering from COVID-19. And then asked them about their household hygiene and behaviours during the pandemic. They found that the virus spread from the first infected person to other family members in 41 out of 124 families. Frequent use of bleach or disinfectants for household cleaning, together with wearing face masks at home before symptoms emerged, all helped to reduce the risk of spread. However, close daily contact, such as eating meals around the table and watching TV together, were all associated with an 18-fold increased risk. Iran has launched a series of cyber attacks designed to prevent other countries from developing a vaccine against the COVID-19 coronavirus. The attacks have been traced to a cell within the Islamic Revolutionary Guard in Tehran. Israeli intelligence sources say that these latest attacks are no longer trying to steal information or intelligence about the research, but rather deliberate attempts to disrupt or destroy work on a cure or preventative vaccine for the disease. These latest moves follows April's cyber attack by Tehran against Israel's water infrastructure. The Islamic Revolutionary Guards try to increase levels of chlorine and other chemicals in the water flowing to residential areas, a move which, had it succeeded, would have resulted in hundreds of thousands of people becoming ill. Security experts say the cyber attack was more sophisticated than what the Israelis thought was possible and was very nearly successful. The Iranians had hacked into software which runs the pumps after routing through American and European servers to hide the source. Israel then reportedly retaliated by launching its own cyber attack against Iran's Shahid Raji container terminal at the Bandar Abbas port, shutting down port operations for several days and creating traffic jams tens of kilometres long. A new study warns that climate change will make more intense droughts more common in Australia. The findings are based on new analysis of climate model projections by scientists from the Australian Research Council's Centre of Excellence for Climate Extremes. The study, reported in the journal Geophysical Research Letters, shows southwestern Australia and parts of southern Australia will see longer, more intense droughts caused by a lack of rainfall due to climate change. But Australia isn't alone. Across the globe, several important agricultural and forested regions in the Amazon, the Mediterranean and southern Africa can also expect more frequent and intense droughts due to global warming. Scientists have developed a new sorbent material which can purify water from radioactive elements. A report in the journal Materials Science claims the new sorbent is based on a tungsten-bronze compound powder. It's designed to purify both industrial and drinking water from hazardous radionucleotides cesium-137 and strontium-90, as well as processing liquid radioactive waste from nuclear plants. The waste product can then be converted into high-density ceramics for safe disposal. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, CastBox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.